Okay, so let's have a look at these reaction schemes. We've got four reaction schemes: 11, 12, 13, and 14. Um, the There are, I guess, one-step reaction schemes and two-step reaction schemes. Remember, we're going to be thinking about using elimination, addition, substitution reactions here. Um, we have to draw down what we think either reactant or product that's missing might be, what the reagent might be, or the type of reaction that is occurring. So if you want to work that out first, just pause the video, write down the answers to these, and then start the video again, and you can go over your answers. Okay, so let's look at problem 11 here. Problem 11 here is a double bond. So initially, of course, we're thinking addition. They've got H2 and a nickel catalyst. Of course, this is hydrogenation, or the type of reaction we could be less more generic and just say it's an addition reaction. We are going to break the double bond and add a hydrogen to each point where it was broken, and we get propane made here. Okay, problem 12. Again, we have a propane here. This is a double bond. We can see that there are two possible products. So because it's a double bond and we're producing two proper products, we're thinking, okay, this must be Markovnikov's rule in action here. So we must have added a hydrogen attached to a halogen or an H2O. In any case, this is an addition reaction. We can see here that we have added an OH and an H here, so we must have added water in the presence of acid, so we could have written that down as H2O/H plus. And when we broke this double bond and we added the H to one side and the OH to the other side, we could either add the OH to the first carbon or the second carbon. The minor product is when we add the OH to the first carbon, and the major product is when we add it to the second carbon, because remember, the majority of the time the hydrogen will add to the carbon that had the most hydrogens attached to it initially. Okay, problem 13. So we have two steps here. So at the end we can see that we have an alcohol produced, and it has this frame of 3 carbons in a row with a methyl group coming off the middle, so that's going to stay consistent. We can see the reagent we added to get to here was potassium hydroxide aqueous, and remember, when we have potassium hydroxide in aqueous solution, it's producing an alcohol. So and that's correct, but the way that it produced the alcohol was it did a substitution reaction, so it must have started from a haloalkane. Now let's look a bit further higher in this scheme, where we can see that they had added hydrogen bromide. So the haloalkane that it must have been a haloalkane with a bromine attached, and because it was substituent, the bromine would have been attached where the OH is attached. So this is a substitution reaction, and this is the molecule it must be. The exact same molecule, but with the bromine in the place of the OH. Now, because the bromine is here in this intermediate organic molecule, the compound B, then when we added hydrogen bromide, it was most likely added, this reaction occurred because there isn't a major or minor product here. So if we'd added hydrogen bromide and there had been a major or minor product, then what we would have known is that it would have been a double bond. But because there's only one product shown here, I'm just going to assume that this was a substitution reaction. And actually, the reagent that the organic molecule they started with here is going to be the same molecule we made in the end. Okay, the bromine. 1 bromo 2 methyl propane, and this is a substitution reaction as well. You could have put down an alkene here, but if you had, remember, you would have had two products. So I'm going to go here with this was just the same initial reactant as the final product. Okay, problem 14. Okay, so we've got here this alkene in the middle. Where did it come from? We've got concentrated H2SO4. That means that this has taken away a water an OH and a hydrogen. There's two possible answers to this. It could have been the OH in the middle, or it could have been on the left. You choose which one you wanted. This is an elimination reaction. heat and catalyst. Okay, yeah, I remember this now. There's no other reaction apart from we're heating it, we're putting a catalyst in. So this is undergo break its double bond and join in repeating units. It's going to undergo polymerization or addition polymerization. And this is the product we're going to have here. And these are the answers. Remember problem 13, instead of putting the halo alkane here, you could have put down an alkene, but just remember that it would have actually formed two products. Thanks for listening. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.